Good morning. Today I would like to introduce Graham Provost of Corys. He is the Vice President of Strategy and Business Development. Good morning.
Morning, Rick. How are you?
How are you today?
Good.
So let's start by explaining what Corys is and what you guys do.
Yeah, sure thing. Corys is a company based out of Grenoble, France, with offices here in the Americas in Houston, Texas, and also Jacksonville, Florida. We're a pure dynamic simulation company. We build software and perform services to build advanced digital twins that are used for a few different things. Process design, code validation, control checkout for process automation and controls development, and then long-term for operator training. So the same software that is used to build, to design the facility and design the controls is then also used as an operator training tool and a digital twin long-term. And we fit for most of our clients into their long-term digital twin strategy, where they're taking an advanced chemical and or deep process model that replicates every asset that they have down to the component level, down to all of the equipment sizing, and then makes it work within the entire process such that they can run through a full startup, shutdown, upsets, and connect all of that to a host of different things. We're fully agnostic with respect to vendors that we can connect to. We're an independent company. We're not publicly traded, and we do what makes sense for our clients. And we what we build fits into their digital twin strategy.
Wow. Obviously, mathematically modeling processes can provide great value and understanding if you can understand how to design a process and then how it will operate. So in general, you are providing models and simulations for which vertical industries?
Yeah, so good question. We work in a number of different industries. So we have three main verticals, one being the process industry. So that for us is oil, gas, chemical, and petrochemical, where we have oil and gas majors. We do everything from LNG processing to every single type of refinery to also manufacturing in some instances. So that's one of our verticals. It's a good portion of our business. The other two verticals are nuclear power, where we have the majority of the market share around the world in building nuclear power plant simulation. And that is everything from balance of plant models for the engine rooms to nucleonics models that are deep nuclear engineering models that can do root cause analysis on accidents, things like that, and deploy that sort of operator training. That vertical builds simulations that are large scale control room replicas. We build the software and also the hardware for that. The last vertical that we work in is transportation. So we build almost all of the rail simulation models around the world. So whether it's the New York City subway system or high-speed rail in Japan, we are building the rail simulators that train all of the train drivers around the world. And that's everything, including what's in the cab, how they drive the train, and then all of the routes and all of the geospatial and geoinformation system for the exact locations of all of the controls, as well as the visual environment that those train drivers function within.
Well, fantastic. But in my mind, that opens up several questions.
Okay.
In the chemical, oil, and gas sector, that means you must have models that understand how all the types of equipment that appear there, that's pumps and compressors and distillation columns and reactors. So you must have the full physical properties of all kinds of mixtures, all the complicated things, azeotropes and any other phenomena that has to occur. You must have to have expertise in that type of modeling.
That's exactly right. And so our software platform and our product that handles that is called Indus Plus, and it is the deepest chemical engineering platform, the most mature platform that's on the market today. Whereby we model everything at the first principle level, such that we're providing a direct replica, an exact digital twin of what is included in the process, and then how it functions within the process and how it interacts with all of the components, all the piping around it, from a physical standpoint as well as from a chemical engineering standpoint.
So you could use those models in kind of a steady state heat and material balance type of flow sheet to kind of lay out a process, but right. You also take those to the next level and they are dynamic, real-time, interacting with the control system, and possibly even faster or slower than real-time.
That's correct. So actually, a lot of our clients don't need to use steady state models anymore. They simply use our software, our dynamic simulation software, to bypass the work that they had historically done in engineering and control engineering to design the system, and just do it dynamically from the get-go. Then long term, that same engineering design tool can be used as a training simulator that you can do absolutely anything with. You know, once we validate the model and it's built and it's running, you can run through any sort of malfunction, any sort of accident analysis, any abnormal condition that you want, and or just things that are difficult for people to do. If you want to look at changing plant conditions, if you want to look at the outside environment and how that's going to affect the way your facility operates, or if you want to look at, for instance, different feedstocks. If we're looking at electrification, if we're looking at changing feedstocks to particular facilities, what are the impacts of that going to be? How is it going to affect the equipment that's within the process already? What sort of capital investment do you need to make? And then how do you actually need to train your people to be able to operate those things long term?
So let's move over to the power sector. I understand that you guys can model and simulate gas power plants, combined cycle, simple cycle, but also nuclear power. All right. So in the nuclear power space, you know, there are some new developments in small modular reactors and advanced reactors. Tell us what Corys is doing to model and simulate in these spaces.
Yeah. So in the nuclear power space, we build everything from we build any sort of reactor that you would want to build for nuclear power. For small modular reactors, SMRs, and some of the newer developments that are coming out. You know, SMRs are actually nothing new. The US Navy and navies around the world have been doing it for a very long time. We build those types of models as well. They're just smaller scale modular models, such that if you need to raise the capacity of your particular site, for instance, a 20 megawatt SMR, it's the same model that you would build for a 200 megawatt power plant. It's just you're building it modularly.
And you can model and simulate the full nucleonics, all of the nuclear reactions, the heat of release from nuclear reactions, and possibly even meltdown situations to train for very hopefully abnormal situations.
Absolutely. We have different versions of our nuclear power simulation software. There are different versions of it's a product called Thor that handle that modeling in different ways. So it's for our clients, it's a question of the complexity and having the product scope and the product set that they can deploy most advantageously for the investment that they want to make, depending on what it is they need to do. But we can build simulations of full nucleonics models that can replicate accidents in any way, shape, and form.
Wow, great. And now in the rail sector, your third major vertical, you say that you model and simulate subways, the whole distribution system, and also in a kind of a full 3D virtual reality way.
Right. So if you think about the person who's driving the train, we've all ridden on trains, we've looked out the window, those things change year over year. If you drive the same route or you ride the same route, you'll notice changes to the buildings, maybe changes to the viewpoint that the driver would see. So we integrate with some partner products that provide overhead digital twins that we then use AI to layer on top of the existing train routes that we have, such that we're keeping the visual route data up to date with respect to real time, exactly what train drivers are actually seeing on their routes, and we keep that information current, such that when somebody makes an investment in that simulation, then what somebody is looking at long term, we're constantly updating the model so that it's as accurate as possible for safety of the public.
And so those models are also including the model of the vehicles, the trains themselves, and also the switching gear and all of the signaling that might have occurred along the way, and possibly even failures in that signaling.
Yeah, correct. We have, and some of it's been driven by positive train control and some advances that have come out. But in terms of the physical cab and the types of models that we build everything from as simple as a few screens in front of you to a joystick and all the base level controls to a full replica of the entire cab that looks and feels exactly like what the driver sees when they sit in the cab itself.
Great. Thank you very much, Graham. Really appreciate getting an update from you.
Yeah, thanks. Thank you, Rick.
I've been speaking with Graham Provost from Corys. Thank you for watching.